This is the video for day 2 of section 10-4 on dividing polynomials. In this video, we will learn a second way to divide polynomials, which is called synthetic division. Synthetic division is a shorthand method of dividing a polynomial by a linear binomial by using only the coefficients. For synthetic division to work, the polynomial must be written in standard form using 0 and a coefficient for any missing terms, and the divisor must be in the form of x minus a. So the steps that we're going to take to use synthetic division, in step 1 it says to write the coefficient of the dividend, which in this case they're doing 2x squared plus 7x plus 9 divided by x plus 2. So your coefficients of your dividend are 2, 7, and 9. And in this upper left-hand corner, in a little box by itself, you're going to put basically the opposite of whatever this is saying. So if it's x plus 2, the a value is really negative 2 because it's in the form of x minus a. So if this is x minus 2, then a value would be positive 2. So we have the a value here, and then our coefficients of our dividend. Then what you're going to do first is bring down that first number. So in this case, we're going to bring down that 2. Step 2 then is going to be to multiply this 2 times your a value, which is negative 2, which gives me negative 4. And that value goes under the next number. Then you're going to add these two numbers to get the 3. Then you're going to multiply these again. So negative 2 times 3 is negative 6, and that goes in the next row, or next column. And then you're going to add 9 and negative 6 to get 3. And since we have no other numbers over here, we're finished. And so our final answer is, if we started with an x squared, this number is now an x, and then your coefficient. So it's going to be 2x plus 3. You have a remainder of 3, so then we're going to write it as plus 3 over x plus 2. And this will make a little bit more sense as we keep working examples. So in our first thing we're going to look at is, are there any missing terms? If I start with my highest degree of x squared, that means I need an x and then x to the 0, which is always just the number. So we have x squared, we have x, and a number. So we're good. There's nothing missing. Second thing I'm going to do, this is in the form of x minus a. So a is really positive 1/3, not negative 1/3. So in this little box by itself, I'm going to put the 1/3. Then I'm going to write out the coefficients of each of my terms. So in this case is 3, 9, and negative 2. I'm going to bring down the first number, which is 3. Then I'm going to multiply. So 3 times 1/3 is 1. I'm going to add these two numbers. So 9 plus 1 is 10. Then I'm going to multiply times the a. So 10 times 1/3 would be 10/3. And then I'm going to add these and convert it back to a fraction, which in this case I get 4/3. So now we have our numbers. I go back and I look. I started with an x squared. That means this is now an x. So that's going to be 3x plus 10. This is your remainder. So it's going to be plus 4/3 over x minus 1/3. Let's try another. So I look at what I'm dividing by, which is x plus 2. Remember, this is really in the form of x minus a, so a is really a negative 2. If I look at my degrees, I go 4, 3, 1, 0. So that tells me the square is missing. So when I write out my numbers here, I have the x to the 4th. There's a negative 1 and x to the 3rd. X squared is not there, so I'm going to have to put in a 0. Then your number in front of your x, and then your number in front of x to the 0, which is where x is not there. So bring down your first number, multiply these, so negative 2 times 3 is negative 6, add, that gives me negative 7, multiply, so negative 7 times negative 2 is 14. 0 plus 14 is 14. 14 times negative 2 is negative 28. 5 plus negative 28 is negative 23. Multiply, so negative 23 times negative 2 is going to be a positive 46. Add these together, you get 45. So since I started with an x to the fourth, that means this first one is x to the third. So my answer is going to be 3x to the third minus 7x squared plus 14x minus 23. The remainder is a positive, so plus 45 over x plus 2. Let's do one more. So our a value is going to be a positive 6. We go from a squared to x to the first to x to the 0, so nothing's missing. So the coefficient in front of the x squared is 1. In front of the x is negative 3. And then we have negative 18. Carry the 1 down. 1 times 6 is 6. Negative 3 plus 6 is 3. 3 times 6 is 18. Negative 18 plus 18 is 0. So since we started with x squared, this is now in place of the x. So that's just x plus 3. Now, make note here that since our remainder is 0, that tells me that x minus 6 is a factor of x squared minus 3x minus 18. I say this because you may have a question that may say, is x plus 5 a factor of, and then given a polynomial? And how you can tell is if you use synthetic division and your remainder comes out to be 0, then you can say that yes, it is a factor. If your remainder isn't 0, then it's not a factor. Synthetic division can be used to evaluate polynomials. This process is what we call synthetic substitution. The process of synthetic substitution is exactly the same as the process of synthetic division, but the final answer is interpreted differently, as described in the remainder theorem. The remainder theorem says that if a polynomial function, p of x, is divided by x minus a, then the remainder, r, is the value at p of a. So for example, over here we divided x to the third minus 4x squared plus 5x plus 1 by x minus 3, and we have a remainder of 7. So I can say that the value of the function p at 3 is 7. So let's try some of these examples. It says use synthetic substitution to evaluate the polynomial for the given value. So first thing we're going to do is set it up. We know that in this case we got x equals 2, so 2 is going to go in the box. We have an x to the third, x squared, x, and x to the 0, so we don't have to put any zeros in. So our coefficients are 2, 5, negative 1, and 7. Carry down the 2. 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. Negative 1 plus 18 is 17. 2 times 17 is 34. And 7 plus 34 is 41. So I can say that the value of the function at 2 is equal to 41. The next one says, evaluate p of x of 6x to the fourth minus 25x to the third minus 3x plus 5 for x equals negative 1/3. So we're going to evaluate it for negative 1/3. We have x to the fourth, x cubed. We don't have an x squared, so that means we're going to have to remember to put in a 0, and x, and then x to the 0. So my coefficients are going to be 6, negative 25, 0, negative 3, and 5. So bring down my 6. 6 times negative 1/3 is negative 2. Negative 25 plus negative 2 is negative 27. Negative 27 times negative 1/3 is 9. 0 plus 9 is 9. 9 times negative 1/3 is negative 3. Negative 3 plus negative 3 is negative 6. Negative 6 times negative 1/3 is 2. And 2 plus 5 is 7. So here our remainder is 7. So we can say that the function's value at negative 1/3 is equal to 7. One more. Says p of x equals x to the third plus 3x squared plus 4 for x equals negative 3. So negative 3 is the number I'm evaluating for. We have x to the third, x squared. Oh, we don't have an x, so we're going to have to plug in a 0. And then we have our 4. So our coefficients are 1, 3, 0, and 4. So I'm going to bring down the first one, which is 1. 1 times negative 3 is negative 3. 0 plus negative 3 is 0. 0 times negative 3 is 0. 0 plus 0 is 0. 0 times negative 3 is 0. And 4 plus 0 is 4. So we can say that the function p of negative 3 is equal to 4. And this is the process of synthetic substitution.